Okay, we are going to work through example 6. So example 5, take a look at the answer key sheet provided on Google Classroom and see if you can't work your way through that one. It's going to be very similar to this one, but this one is actually going to involve long division. We have to do long division because we will be dividing by something that is non-linear. So x squared plus 3 as opposed to just x plus 3. Now again, we know that we need to use long division because we cannot clearly see the derivative of any expression present. So in our numerator, we've got x cubed minus 3x squared plus 4x minus 9. If we wanted that to be u, we would need to see somewhere the derivative of that, which would be 3x squared minus 6x plus 4, which we very clearly do not see. So because of that, number 2, because the degree in our numerator is greater than or equal to the degree of our denominator, and then also because we have a polynomial on top and a polynomial on bottom. We have a rational expression. We know we need to use long division. So we are going to set up our long division. We have x squared plus 3 on the outside, and then on the inside, x cubed minus 3x squared plus 4x minus 9. So then remind yourself, long division, what do we need to take x squared by in order to get x cubed? Well, we need one more x. I like to line it up, put my x term above my x, but that's just me. So we'll take x times x squared to get x cubed. X times 3 will give us 3x. Notice we have that little gap, but that's okay. We need to subtract, because that's what long division tells us we need to do. X cubed minus x cubed, they cancel. Negative 3x squared minus nothing is going to remain negative 3x squared. 4x minus 3x is going to give us a positive 1x, and we bring down that minus 9 as you do. So then we say x squared times what will get you negative 3x squared? Well, that's going to be a negative 3. So negative 3 times x squared is negative 3x squared. Negative 3 times positive 3 gives us a negative 9, and we subtract. Negative 3x squared minus negative 3x squared cancel. 1x minus nothing is a 1x. Negative 9 minus negative 9 does cancel. So then when we do polynomial long division, our answer is going to be our quotient, that x minus 3, and then plus the remainder written as a fraction with the divisor as your denominator. So now, as opposed to integrating that ugly rational function, it's slightly better because it involves power rule. So it's going to be the antiderivative of x minus 3, which is just going to be power rule, plus our one function that we now have. So x squared plus 3, or one rational function, excuse me, with respect to x. So let's first very quickly find the antiderivative of x minus 3. Well, just reverse power rule. That's going to give us 1/2 x squared minus 3x. So this antiderivative is going to be equal to this part plus the antiderivative of this part, which I'll just write out again because that's what we're going to be focusing on next with respect to x. And then there's going to be plus c in here somewhere that we'll worry about at the end. So now that we are just working with this piece, let's consider, do we have a u du situation? And we do, because our denominator, if we let x squared plus 3 be u, then du dx will be 2x, right? And we have close to that, we have an x. And again, as you start to get good at guess and check, you can call it 2x as long as you put in 1/2 out front. But if we want to go the longhand way, then we can say, okay, du dx is 2x, and then that would make dx equal to du over 2x. So then that definite integral, and we'll just copy everything down, 1/2 x squared minus 3x plus, now all of a sudden it's turned into x over u, right, x squared plus 3, times dx, well, dx was du over 2x. Your x's cancel, which is good. And then, like I said, that 1/2 comes out front. So all of this in terms of u is going to be 1/2 times the integral of 1 over u du. So our total antiderivative is 1/2 x squared minus 3x plus 1/2 times the natural log of the absolute value of u, and then we can throw that plus c on at the very end. And then lastly, we want to replace u with what we know u to be equal to, x squared plus 3. So final answer, 1/2 x squared minus 3x plus 1/2 times the natural log of the x squared of the absolute value of x squared plus 3 plus c. Now, one last thing to note, we do not technically officially need the absolute values around that natural log expression, because if you take a number and you square it and then you add something, that will for sure be positive. So if you want the absolute values, great. If not, don't worry about them, because they serve no purpose this time around. So be on the lookout for when you need to use polynomial long division. And notice that you don't always have to do long division. You can do synthetic division like we would have done in example 5 up above.